My name is Joe Trout, and I'm from the physics program. And uh, here's a list of our faculty. And what you can see is that we have people that are interested that do research in acoustics, in quantum optics, in biophysics. Dr. Russ Manson, who's one of my colleagues, does mathematical modeling, and he does things like the flow of rivers through Poland and things like that. Chipper Powell does solid state physics, and Benita does forensics physics. We have an engineering program that we'll talk about, and Manir does mostly engineering. Yitzhak does how the nucleus of the atom is held together, and I do mostly atmospheric physics and some astronomy and astrophysics. So the first thing is that what can you do with a physics degree? Right, about 60% of our students go to graduate school and do research first, and about 40% go straight into employment, right? And for those people, we have private sector jobs are about 53%. So normally people with a degree in physics, they'll do things like work in research labs. When I first graduated from Stockton, I was working in a lab that was finding new uses for Teflon and things like that, because Teflon has really low friction coefficient, so it's good for lots of things. And then some people go into teaching for high school and grade school. Some people go in the military, and then about 10% go into government or national labs. So if we look for people with just a bachelor's degree in physics, a fair number of them going to engineering or computer systems. There's other STEM opportunities, which is science, technology, and engineering and mathematics. And about a quarter of them go into non-STEM fields. So really with a degree in physics, you can work in almost any industry, depending on what your interests are. So for instance, people do mathematical modeling of the economy, for instance, and a background in physics will help you with that because you learn about how to model systems. And at Stockton, we have an applied physics department. So this uses physics to solve everyday practical problems. So that's what we're about. So we have a really hands-on curriculum. So for instance, I teach electronics and optics, and almost 3/4 of that class are labs where you're working with electronics and optics, and only about a quarter of it is actual lecture. And but we do cover all the theory of how it works. But we like to have people have a hands-on approach, get to work with the equipment, and get a feeling for what it really means to study physics and to work in physics. So several of our classes, like I said, optics and electronics, our advanced physics lab. We actually have a FEM microscope, so we can look at objects that are smaller than a wavelength of light. So we work with that. We also have, like I said, not only electronics, but we also have a course in circuit analysis. And we also stress our computational skills. So for instance, I have students that are working on the data that came down from the Kepler telescope and looking at how, and looking for planets and seeing how stars evolve. And we also do a lot of weather research. So we're doing a study with the climate right now, where we're looking at using tomatoes that mature much faster. And the physics comes in that we have to be able to predict when the last frost will be pretty accurately, so we can get these into the ground at the proper time. So we do a lot with computers, with computer modeling. Right, and you'll get computer skills through all of your courses at Stockton. So if we look at a quick snapshot of what will happen, at first you take your first 3 years, or first 3 courses are physics 1, 2, and 3, right? which are basic physics courses. Then we have a computational and mechanics course. We talk about quantum mechanics, optics, electronics. Colloquium is a neat course, which you go and you listen to people who are in the field right now, and they talk about their research, or I bring in people that have jobs in industry, and they talk about what they do as a physicist. Nonlinear systems are things like, how do we keep bridges standing up while their weather's going through, right? So for instance, weather can introduce some nonlinear dynamics. I'm sure you may have seen the video of Galloping Gertie. If not, after you get off, take a look at it. And what happened was there was small gusts of wind that caused like a bridge about the size of the Ben Franklin Bridge to start to oscillate wildly, and finally it fell down, right? So nonlinear systems looks at things like that. We also have mathematical physics. I also teach that, and research methods. So everybody who's a pure physics major has to do a undergraduate thesis. And like I said, some of my students are looking at Kepler telescope data. Some of them are working on that tomato project. We also have somebody who's looking at how wheat is grown and the physics of that. So these are all different projects. We also have, for acoustics, Neil Aronson works with his students, and they try to help out the Navy with how sound affects the sailors that in submarines, and how the headphones and things affect them. So there's all kinds of research to be done here. The good thing about Stockton is you can start your research as a freshman. So I have really good freshmen that their second semester as a freshman have started doing research with me, right? So if you're good, you can start your research really early. And I think that's really important if you want to get out into industry and do research, or if you want to get into graduate school. So you can look this up on the web, but here's pretty much the courses you'll be taking, right? Physics 1, 2, and 3, calculus 1, 2, and 3, differential equations. And then like I said, this colloquium course where we have people come in and talk to you about what it really means to be a physicist, right? Optics, electronics, linear algebra, thermal physics, and research methods. And then there's some G courses that we could talk about sometime. So what these are interdisciplinary courses that we offer at Stockton. If there's anybody on the line that is interested in being an engineer, yes, no? So can everybody, I'm assuming everybody can hear me, right? So is there anybody that's interested in being an engineer?
To some extent, I like everything, so I'm just here to inform myself a bit more.
Okay, so we have an engineering program that's, you spend 3 years at Stockton and then 2 years at an engineering school. And the good thing is that Stockton has really small classes. So for your beginning classes, like Physics 1 and Physics 2 and Physics 3, and for your calculus courses, you'll take them at Stockton where it's less expensive, and we have good professors and everything that can help you get through these courses. I came from Drexel University, so that's where I did my PhD research. And there I was teaching, 150, 200 engineers at a time in a big lecture classroom. And that's great. I love Drexel. But I would have rather had seen like smaller classes at the early courses. And then when you came to Drexel, you would do the engineering classes. So we have relationships with Rowan and Rutgers and NJIT. And what you'll do is like I said, do the first 3 years at Stockton, and then do the 2 years at the engineering school. And what you come out with are 2 degrees, one in physics and one in engineering. And basically, for instance, in the engineering, you take Physics 1 and 2, statics, which has to do with how forces relate, for instance, when building bridges. and then physics 3 and mechanics. And you'll also take chemistry 1 and 4 and some math courses and electronics or optics, and then some other G courses that we talk about. We also have this idea of this general studies program, and the idea is that Stockton has, we come up with courses that are interdisciplinary. So I'll give you a couple of examples of these courses, but they're taught by all the faculty members, and sometimes like a physicist and a chemist will get together and teach a course, or for instance, or a biologist and a chemist or something like that. And the courses may study a problem or a theme or survey related topics, right? And these courses are designed to explore ideas and stimulate critical thinking, right? But in a more interdisciplinary approach. And these are the type of courses there are. There's general arts and humanities and general natural science and mathematics. And that's mostly what our professors teach. So here's some good examples. I teach a course in severe weather and climate. And we talk not only about the weather, but we talk about historical storms that have come through and how we prepared for them and if our preparations were successful, right? For instance, we find that we're doing much better at predicting hurricanes. So fewer people are dying, but there is much more damage because people are moving closer to the beach because they like the beach. So we study things like that in that course. Neil, our acoustics person, he studies sound and music. So he also runs the Stockton a cappella group, but they study how sound is, how physics relates to sound in this course. Yitzhak teaches a course in Man-Atom Universe, and they study everything from UFOs to black holes. And we have a professor who does medical physics, and she teaches a course in medical technology, and for instance, how fiber optics can help doctors in treating patients or doing their initial studies, or how ultrasound works and how lasers are being used. I also teach a course called The Science of Ice Cream. So we study how physics affects ice cream. So for instance, they actually make ice cream in the labs, and we change the structure of the ice cream to find out how different things are working. So there's some that are kind of fun, and there's some that are really serious. Like I said, that severe weather course is pretty serious, and the ice cream class, we learn just as much physics, but it's a little more fun. We also have undergraduate research, and most of my students, after they do a year or two of research, go on to present at some national conference. So there is a senior research requirement, so you have to do a research project. But like I said, if you're good, you can start your freshman year, start working on research. Some of the opportunities are paid, some of them are unpaid, most of them are unpaid, I won't lie to you, right? But there are research positions available. And then we publish our findings and also present at national conferences. So we just had 2 papers published in scientific journals from my students and myself, and they also present a lot. So in fact, most of them were supposed to be presenting next week, but sadly, due to the virus, that meeting was canceled. But they go and present their work, and they get information from other scientists to help them improve their work. And they also get to meet potential employers and graduate professors so that they can go on to graduate school. Well, here's some of the conferences that my students have presented at: the American Physical Society and the American Association of Physics Teachers. In fact, I have a student who is working, she wants to become a teacher, so she's developing an online course for astronomy. And that's what her senior project is, and it's going really well. And she just published a paper with myself about the ice cream course and how it is used to teach physics. We also have the Society of Physics Students Conference. So one thing that Stockton's really good about is that we have students that really form a strong community. So we have a really good physics club. And last year they traveled to CERN to see the collider, and they help each other get through their courses. And also they tutor other students who aren't physics majors that have to take physics. And Stockton also has 2 events where they can present what their research is. So if you like doing research and projects, then Stockton's a really good place to go to. This was a study we did with the FAA, and I don't know if you know this, but if you have planes, as they fly through the air, these rotating vortices, like in essence, little tornadoes come off the back. And it defines how close you can put planes together when they're landing. So for instance, if this was a big giant airliner and there was a little propeller plane behind it, what could happen is it gets caught in these wake vortex, and they get forced to the ground and can cause crashes and things. So what we have to do is define how close they are. So we had a study with them that involved a couple of students, and what we were looking at is how weather affected these. So I don't personally want them to land the planes any closer together, but it would be good to know that, for instance, if a plane was in trouble or caught fire or something, that you could get it out of the air quickly and safely. And that's what we were working on. So this shows some of their work. And this was presented in Washington at an American Physical Society conference. And this was another part of that study. So Dr. Manson was working on how the wind actually went over the airplane wings, and I was working on how the weather affected the airport. So we did studies like this. And like I said, we had David King, Nick DeChico. They were both paid to do this research. They were both juniors and seniors at the time. Here's another thing that we'd like to work on. So this is some temperature data. So some climate data that we presented on at, I believe this was APS, but I can't see the thing, the name. This is a couple years ago. And we do study on physics education. So we do some studies on that. So if we look at our physics faculty, Stockton's a really teaching-centric model. So we want the teacher and scholar the teachers to be both teachers and scholars. So our professors are teachers, right? And they're working professionals, and then they engage in scholarship. So we have to do do research and publish papers. And we also take part in college governance. So we help lead the college. Like I said, here's some of the interests that we have: material science, biomedical, and atmospheric physics. So as Stockton physics students, we hope that by the time you leave, you're really strong in mathematics, you have good oral and written communication skills, and you understand, you can work in a group, and you can also work independently. And we also work on data interpretation. So for instance, as I said, we can collect lots of weather data, but unless we look at it and try to figure out what's happening with the atmosphere, then it's kind of a waste of time, right? So we look at how the climate is being affected in the long term. By the way, stop me at any time if you have any questions, right? Our Society of Physics students, like I said, they're really strong, and they meet, and for instance, the faculty and the students will have dinner every couple of weeks with the Society of Physics students, and they offer tutoring for free to the other students, right? And like I said, they do external trips. And there's also a Sigma Pi Sigma, which is the SPS, which is the National Physics Honor Society. So you're, after 3 physics courses, if you have a good enough average, you can get into the National Honor Society and take even more trips and things. I'm really into service learning. So for instance, here was one of my service learning classes, and this just shows a couple of them, but what we did was get a grant for a poor school in Philadelphia, and we got a grant for about 30 computers, and we built them a computer lab. So we put all the computers together, and this was part of our introductory physics course. And I also like active learning. So I have a service learning course, my Physics 1 course. So this is one of the students. These are the students that are there. And what happens is, instead of me doing the demonstrations in class, I'll teach groups of students how to do the demonstration. So I don't know if you ever saw this. This is the human gyroscope. So that young student is on a rotating platform, and if he tilts the wheel, he'll spin around. But what happens is the students learn that demonstration, and they present it to our physics class. So everybody's a member of a group, and everybody learns a demonstration, and we do it there. So then at the end of the semester, we invite a grade school to come in, so 7th and 8th graders, and they teach what they learned in class to these 7th and 8th graders. So here we see one of the stations, and this is talking about rotary motion. And here's another one. They were talking about how to build a star. So you can tell which one's the Stockton student. That's the tallest one, right? But this was another school, that inner city school, that wouldn't get a chance to do this normally. So I thought I think the students really enjoy it. We have a good time doing it. And I think it's a good way to learn physics, is to teach other people. Once again, the human gyroscope is one of the most fun ones. So this shows one of the students from the school, and some of my students teaching them how to do it, how it works. The same day, we have one of the chemists come in, and we make liquid nitrogen ice cream. So that steam you see coming up is the liquid nitrogen. And then the college students, so my freshman physics class, has lunch, pizza and liquid nitrogen ice cream, and talk to them about, and talk to the younger students about how to become scientists. And finally, make this little apparatus that makes laser designs. So that shows one of my students showing them how to do it, and one of the younger students exasperated for some reason. Something wasn't working right, but I think they really enjoy the whole opportunity. So after graduating, where do our students go? They go to Drexel, and they go to, we also have a master's program in data analysis at Stockton. They end up at NJIT, Syracuse, and Columbia, University of Maryland, and Rutgers. And I always forget who this is, but also the Polytechnic Institute. That's probably pretty much Stockton in a nutshell. Anybody have any questions or anything that you want to talk about Stockton? If you haven't been to Stockton, it's in a great area. So it's in the middle of the Pine Barrens. There's some great running trails. We're about 20 minutes from the beach and about an hour from Philadelphia, and there's a train to Philadelphia. We take some trips to go to see the other colleges at times, to see other speakers and things. So any questions about anything? Okay, if not, it was nice to talk to you, and I'll see you all later.